We are going to move forward with the junior penetration tester path on TryHackMe. Right now we are on Authentication Bypass. Yesterday we covered subdomain enumeration, which was really interesting. So let's see what Authentication Bypass is all about. And as I've said previously, I'm gonna add my own twist to these videos because probably there have been many others before me who've actually done videos on walkthroughs for for these rooms or for these paths on YouTube. Therefore, it wouldn't be wise, or it wouldn't be advisable, or it wouldn't be okay for me just to keep on adding on to the spam of the information that's out there on the internet. So let's actually start the attack box and also the machine. I don't want to do the mistake that I've done in a previous video if you've been watching this series. Now in this room we'll learn about different ways website authentication methods can be bypassed, defeated, or broken. These vulnerabilities can be some of the most critical as it often ends in leaks of customer information. To be honest, in my penetration tests so far, I haven't met with too many circumstances where I was dealing with authentication bypass scenarios, but previously, as I've been doing bug bounties on certain private programs on Synack, there have been situations when I encountered this issue. Not necessarily as of myself or as of an original issue that I found, but as a catch in a certain scan with a certain automation tool. Alright, start the machine and proceed to the next task. User enumeration. Alright, so we are actually recording, I just want to make sure. A helpful exercise to complete when trying to find authentication vulnerabilities is creating a list of valid usernames, which we'll use later in other tasks. Now, as I see it, for example, if you're dealing with the custom built login panel, they might not have done their entire homework because there are a lot of scenarios that you have to account when it comes to securing a certain asset. Therefore, if they are not using, if the company, the developers, or whatever you're actually dealing, the type of asset you're dealing with, if they're not using some sort of a framework or an already implemented method, if they're actually building things custom, there is a lot of room for error, and those are situations where you are very likely to encounter authentication bypass issues. Now, I'm going to try to keep this video under 20 or 25 minutes, which is why if it's gonna take longer than that, there's actually going to be a 2 or a 3 part for the authentication bypass room. Now, website error messages are great resources for collating this information to build our list of valid usernames. We have a form to create a new user account if we go to the Acme IT support website, which should be, let's actually open it in the browser here, because it's not going to load into my browser but into the browser of the attack machine. So it's 10.10.76.35 customers, and I don't want to actually use the copy paste feature. I'd rather type it out because it was quite easy. So customers sign up. This is probably a custom customer sign up. If you try entering the username admin and fill the other form fields with fake information, you will see we get an error. An account with this username already exists. So admin, domain 2@admin.com, password admin, sign up. An account with this username already exists. The FUF tool uses a list of commonly used usernames to check again for any matches. So we would actually, here's the situation where I want to copy and then use the clipboard here to paste, then copy from there, go into a terminal, and then actually paste it over here. So FUF, we're using the word list, user share word list, sec lists, usernames, names.txt. We're actually doing a post request to the Firefox to this actual page. And the data that we're actually going to send is username equals fuzz and email equals password and email equals X and password equals X, and C password, which is confirmed password, is equal to X minus H. Content type application, so we need to also specify this type of header, and then the URL, which is our URL. Match response username already exists, so we're actually filtering out all the responses that have this username already exists. Filtering out or filtering in. We've got Robert, Simon, and Steve. And admin, of course. And here's where they're actually explaining the command that I just explained. The -h argument is for adding additional headers, as I've said, another additional header, which is content type. Argument is the text on the page we're looking for to validate we found a valid username. Match response. The FUF tool, alright, save the results, valid usernames, which we can use in a later task. So I could actually save the output using the -o command, but we could simply just echo admin into valid usernames .txt, then echo Simon into valid usernames. There was also Robert, echo Robert into valid usernames, and echo Steve into valid usernames with just one E. Then let's actually cat the valid usernames. We have admin, Simon, Robert, and Steve. So the first one is Simon, then there's Steve, and then there's Robert. Brute forcing. Using the valid usernames file we generated in the previous task, we can now use this attempt to brute force attack, or to perform a brute force attack on the login page. Now, this is typically not a real world scenario unless so in 2022 it is least likely that you're gonna find a situation where you have the possibility to actually conduct a brute force, though there might be in existence, such situations might exist. There is least likely because every respectable company or asset or company that has an asset that you're actually testing on, they're going to set up a password policy and also a rate limiting policy when it comes to login attempts. So such scenario is quite unrealistic or very least likely to be encountered in real life situations. A brute force attack, so brute force is a thing of the past, is an automated process that tries a list of common use passwords. When running this command, make sure the terminal is in the same directory. So we're still going to use FUF with our valid usernames. This is a custom. That's an interesting command over there. Let's actually try to see it all out. So W1 user shared word list, common credentials, username W1. So in this case we're actually using We're taking the valid usernames and filling it in our data over here, and then we're taking the password from another word list. And you can simply do that by actually passing two arguments to the -w delimited by a comma. We're doing the same post request, username, password. In this case, we're actually going to the login page and we're filtering for code 200. Alright, so this is where they explain it. In this instance, we've chosen VW1, W1 for our list of valid usernames and W2 for the list of passwords we will try. The multiple word lists are again specified with -w argument but separated with a comma, as I said. For a positive match, we're using the -fc filter for status code. Argument to check for HTTP status code other than 200. No, we're actually... So for FUF, they have FC and MC, match and filter. Running the above command will find a single working username. So in this case, they're actually going to try all the usernames, in this case admin, Simon, Robert, and Steve, with all the passwords from this common credentials 10 million password word list, top 100. So we have 100 passwords, probably. In this case, Steve Thunder. This is the combination that actually worked. So it's Steve Thunder. Alright, logic flaw. So task number 3, quite unrealistic, but it's actually good to know. So this room was created by TryHackMe, but it's actually good to know how to act if you encounter such a situation. How are we on time? 12 minutes. Alright, we might be able to finish it, I guess. Let's see. So, sometimes, what is a logic flaw? Sometimes authentication processes contain logic flaws. And this is a scenario that is very likely to be encountered, and it's a scenario that you won't be able to find it using automation or tools. This is why you as a penetration tester will have a lot of advantages of other people who are just using tools or automation, because you would have an advantage as someone who's checking stuff manually. A logic flaw is when the typical logical path of an application is either bypassed, circumvented, or manipulated by a hacker. Logic flaws can exist in any area of a website, but we're going to concentrate on examples related to authentication in this instance. So the hacker's path is actually from step 1 to step 4 by circumventing or bypassing or manipulating step 2 or 3. And the intended path is to actually going from step 1 to step 4 by going through step 2 and step 3. The below mock code example checks to see whether the start of the path of the client is visiting begins with /admin, and if so, then further checks are made to see whether the client is in fact an admin. If the page doesn't begin with admin, the page is shown to the client. So if URL substring 06 equals, so this is JavaScript probably, admin, so 246, code to check user is an admin, like for example a token or something else, view the page. Because the above PHP code, so it's not JavaScript as they say, even though it looks like JavaScript. Is this PHP? Really? Example uses 3 equal signs. It's looking for an exact match on the string. So exact match, it's what you do in JavaScript. But let's see exact match in PHP. Anyway, I have a feeling that they made a mistake here. The code presents a logic flaw because an unauthenticated user requesting, so they didn't do additional checks. This is exact match. An unauthenticated user requesting admin will not have their privileges checked and have the page displayed to them, totally bypassing the authentication check. So in this case, using 3 equal signs, for admin, you're actually bypassing this, requesting the same page but with different cases for certain characters. We're going to examine the reset password function of the Acme IT support website. We see a form asking for the email address, reset, with the account on which we wish to perform the password request. Password reset. If an invalid email is entered, you'll receive the error message if an invalid. For demonstration purposes, we'll use the email robert@acmeitsupport.thm, which is accepted. We're then presented with the next stage of the form, which asks for the username associated with this login. If we enter the Robert, press the check username. We'll send you a reset email to robert@acmeitsupport. At this stage, you may be wondering what the vulnerability could be in this application, as you have to know both the email and the user, and then the password link is sent to the email address. Now, this walkthrough will require running both of the curl requests on the attack box, which can be used whatever. In the second step of the reset email process, the username is submitted in a post field to the web server, and the email address is sent in the query string request as a get field. Let us illustrate this by using the curl tool to manually request. So let's actually do that. Curl to this page, customer reset, and we have the parameters in the URL, email robert@acmeitsupport, and then so you have the email in the URL, and then you specify data. So this is probably a post request. We use the -h to add additional flag, to add additional header to the request. In this instance, we're setting content type, which lets the web server know we're sending form data so it properly understands it. In the application, the user account is retrieved using the query string, but later the password email is sent using the data found in the PHP variable request. So this is a fairly normally looking PHP variable. So this variable is actually an array that contains data received from the query string. If the same key is used for both query string and post data, the application logic for this variable favors post data fields rather than the query string. So if we add another parameter to the post form, we can control where the password reset email gets delivered. This is more like a parameter pollution situation. So everything probably looks the same. We just need to add an email equals attacker@hacker.com. We'll send you a reset email to attacker@hacker.com. which is exactly what it's in the response over here. For the next step, you'll need to create an account on the Acme IT support customer section. Doing so gives you a unique email address that can be used to create support tickets. The email address in the format is username. Now rerunning curl requests, but with your @Acme IT support in the email field, you'll have a ticket created on your account which contains a link to log you in as Robert. Using Robert's account, you can view their support ticket and reveal a flag. Alright, so let's see. What was it? Sign up. Username Dan. Dan and customer that Acme IT support at THM. Password admin1, admin1. Sign up. Welcome to your customer dashboard. Save. Now let's run this. And email Dan. So what happens in this situation? Using Roberts' account, you can view their support ticket and reveal a flag. Now rerunning curl request too, but with your Acme IT support in the email field, you'll have a ticket created on your account. Let's check it out. See if we have a ticket. Refresh this. Support tickets, password reset. And reveal a flag. Where would the flag be? Would it be over here? Let's actually copy this, paste it, page not found. So we have the support ticket, and that's the new ticket. Alright, the final one. So yeah, sort of like this was kind of convoluted. Wouldn't necessarily say it's the best way to understand authentication bypass, but anyways. Let's see if we can finish this one. Cookie tampering. Examining and editing the cookies set by the web server during your online session can have multiple outcomes, such as unauthenticated access to another user's account, elevated privileges. If you need a refresh from cookies, check out the HTTP in detail. Maybe we'll check it out at some certain point in time if those of you who are watching this video are really interested into that. So again, I want to say what I said in previous videos is that you should share this video on all of your social media, because this actually tells me that I should keep on doing these videos, because if there is interest in watching them, I will be doing them. I don't get anything from YouTube or from TryHackMe to actually do this video, so I'm actually doing it on my free time, when instead I could maybe do some bug bounties on some private programs or maybe study. So you should appreciate that and share the video everywhere so it gets traction, so to speak. The contents of some cookies can be in plain text and it's obvious what they do. Take for example, if these were the cookies after a successful login. Admin equals false, logged in equals true. So the cookie logged in controls whether or not the current user is logged in, and another admin which controls whether the visitor has admin privileges. Using this logic, if we were to change the contents of the cookies and make a request, we'll be able to change our privileges. Interesting. Yeah, so this might happen in the real world as well. Curl, let's just type it out. HTTP 10.10.76.35 cookie test. Not logged in. Now we'll send another request with the logged in cookie. So we'll probably have to specify -h cookie logged in equals true. So remember, we are not authenticated here. We're just modifying a cookie. We're just actually tampering a cookie. Logged in as admin. Is it this one? Yes. Next. Hashing. Sometimes cookie values can look like a long string of random characters. These are called hashes, which are irreversible representation of the original text. Here, and I believe I have some videos on YouTube on how I created a Python script that would actually brute force a hash. Here are some examples that you might come across. So we know that we have hashing methods. One of the most used is MD5, SHA-256, SHA-512, and SHA-1 of the same of a certain string, for example. You can see from the above table that the hash output from the same input string can significantly differ, so these are quite different. Even though the hash is irreversible, the same output is produced every time, which is helpful for us as a service such as CrackStation, which keeps databases of billions of hashes and their originals. Now, encoding is different from hashing, and it actually is similar to hashing in that it creates what would seem to be a random string of text, but in fact the encoding is reversible. So we have hashing, encoding, and encrypting. So it begins the question, what is the point in encoding? Encoding allows us to convert binary data into human readable text. Common encoding types are base 32, which converts binary data to characters A to Z 2 to 7, and base 64, which is a bit more inclusive. Take the below data as an example, which is set by the web server upon logging in. So we have the session, which is a base 64, max age, and the path. The string is base 64, which is what I said, of ID1 admin equals false. We can then encode this back to base 64, encode again, but instead setting the admin value to true, which now gives us admin access. What is the value of the MD5 hash? We can simply do MD5 decrypt. Let's look at this one. (463729). What is the base 64 decoded value of this one? So for that we have base 64 decode, probably one of the most user unfriendly ones, but most widely used ones. And then we encode the following using base 64. So in this case, we're actually going to encode and then just paste it over here, and we're done. Less than 30 minutes.